this memory architecture. Okay, as you know that what do you mean by shared memory, distributed memory. So see here in a shared memory, what happen? One uh, pro memory is there. Shared memory parallel computer vary widely, but generally have in a common the ability for all processor to access all memory as a global address space. It means that a memory, whatever the number of CPUs are connected, they are having a common shared memory, and everyone can use this memory with the help of a global address space. But your shared memory is divided into two class. One is an UMA, and the second one is the non-UMA, that is uniform memory access and the non-uniform memory access. So what happen in case of uniform memory access? Whatever the shared memory is there, and whatever the different CPUs are connected to this shared memory, all they having the equal access and the equal access time to that particular memory. Another concept in the UMA is a cache coherence. Cache coherence means if one particular process updates the locations in the shared memory, then other processor or the CPU will get notified about that updates. That is nothing but the cache coherence. So we are having a cache coherence in the shared memory, where in case of non-uniform memory access, see, I'm just reviewing this memory architecture because you already know about that one. So in non-uniform memory access, what happen? One SMP will be there. Sorry, regarding particular structure, one SMP or more than SMP will be there. All these SMP will be connected together, and they are sharing the memories. They are sharing the memory. So, but one SMP can directly access the memory of the another SMP. So one rectangular box is considered as the one SMP, another rectangular box is considered as a another SMP. So what happen? One SMP can directly connect with the other memory. They can access the memory with the help of these connections. But what happen? Not all processor have equal access time to all memories. Now here, suppose one SMP will be there. Okay, and four different processors are accessing this memory, but it is not equal access time will be given to each and every processor. In case of uniform memory access, we having the equal time access to memory. And here also, so here whatever the memory link we are using, due to that link, okay, the access time, it require the more time for the accessing the memory from one SMP to the another SMP. Again, in this case also, the cache coherence concept is going to be used. Now this is a shared memory where distributed memory will be there. Okay, another concept is the distributed memory. In case of distributed memory, we are not using the cache coherence concept. Okay, so processor have their own local memory. So each and every processor, they are maintaining their own memory, and they are sharing their memory with the other processes. If there is a kind of any kind of data dependency is there, then the memory will be distributed with the other processor. That is your distributed memory. And hybrid memory is nothing but the combinations of your shared memory and the distributed memory. So all type of memory architectures we are going to be used in the parallel computing. Most of the time in the parallel computing, we are using the hybrid kind of memory architecture. Now the important point, okay, see, memory architecture, shared memory, there are two class, either UMA and non-UMA. Second, distributed memory, and the third one is your uh, hybrid memory. Now, implicit parallelism trends in the microprocessor architecture. Now, as we already discussed that the overall processing of any computer system is basically depends on three components. One is your processor, second is memory, and the third one is the data path. So the if you are considering this improvement of processor speed, memory architectures, and the connections between this processor and the memory architecture, there are according to that invention, there are different architectures are there. So if you are using the more than one uh, elements. If you are using the more processing elements or the functional units, then this concept is nothing but the parallelism. If you are having only one memory unit, one functional units, and one data path is there, then this is called as a single computing or the serial computing, we can say that. But in case of single, if you're having a multiple, all things are multiple processors, multiple functional units, multiple memory architectures. So in that case, we can call as a multiplicity. We can say that that is called as a multiplicity, and that is a used in the parallel computing purpose or the for the parallel programming. So one of the versions of your multiplicity is also called as a implicit parallelism. Now in that implicit parallelism, what happened? Microprocessor clock speed have posted impressive gain over the past 2 decades. We already discussed one survey कि microprocessor technology has delivered significant improvement in their clock speed over the past decade. So if you are considering high level of device integrations have made available a large numbers of transistors. If you are considering the uh, clock increment of your in the clock speeds, so but if you are considering the increment in the clock speed, at the same time there is a limitations of your memory technology. So for that purpose, higher level of device integrations have made available a large numbers of transistors. Now what happens? So what happen, you are having a different number of resources, number of functional units, number of memory architecture, number of processors are there. Then the question is how best to utilize these resources is an important one. So suppose number of instructions are there, so which instructions is going to be execute, okay, when some all the instructions or the scheduling of the instructions you need to be defined one. So the current processor we use these resources in the multiple functional units and execute the multiple instruction in the same cycle. It means that within a one cycle, okay, you can use the different functional units and you can execute the multiple instruction. Then and then we can achieve our